Hi, my name is Jack Slutterbach, and I will be presenting my final project for the Information Retrieval class, an analysis of human rights rhetoric. To provide a little background, the corpus of documents I will be covering are the country reports on human rights practices, which I will refer to as human rights reports from now on, published annually by the U.S. Department of State starting in 1976 during the Gerald Ford administration. These reports assess how every country in the world is doing as it relates to human rights from a U.S. perspective. Without delving into too many details, each report is essentially a documentation of human rights abuses, documented into different sections for a particular calendar year, as well as usually some context around laws or general organization of government for that particular country. It's worth mentioning that this latter piece from the documents I read is not consistent. Usually what is consistent is just that documentation of human rights abuses. Naturally, such a set of documents contains a lot of information that is of general interest, as according to the U.S. State Department websites, these documents are meant to guide U.S. foreign policy as it relates to other countries. Or, as they put it explicitly, it is meant to help the U.S. government work to craft strategies to protect human rights of more individuals in more places. So, the experimental hypothesis for this project is a relatively simple one. Can we use the rhetoric of these human rights reports through a naive Bayes classifier to correctly identify a country as aligning with or opposed to the United States government? To do this, we'll not only be using human rights report data, but also data published through the UN. Basically, the idea here is we want an unbiased and simple way to establish is a particular country in the world aligning or opposing as it relates to the U.S. In this sense, UN voting data can be used and countries can be categorized based on their tendency to vote with the United States. In other words, if we vote yes on a resolution in the UN, did another country vote yes? If we voted no, did another country vote no? If we abstained, did another country abstain? Thus, the goals of this project can be thought of as and enumerated here. So first and foremost, collect and curate human rights report data. Do the same for UN resolution voting data. Perform a statistical analysis to establish the aforementioned aligning and opposing countries' relationship. And then finally, train a naive Bayes classifier to correctly classify these human rights documents. So the first step was collecting data. So how was this done? Basically a lot of scraping and a lot of regexes. So the data I collected was between 2012 and 2021 from the UN resolution voting. And for the human rights report, I collected human rights reports from 2015 to 2021. And again, without going into too much detail, this was just because the State Department website undergoes a lot of changes. I became intimately aware of that. And then there's two links here at the bottom for the general places where I got these things. It's worth mentioning there were no APIs. This was literally all web scraping. So next thing is the experimental design of establishing classes, right? So now that we have the input text, the question becomes how do we classify these countries? And here we go back to our overlapping experimental design, basically the overlapping votes between US and other countries. And so here's a simple histogram at the bottom. It's worth mentioning that for percentage ranges that are not on the chart, these simply didn't have any countries in them. But looking at this histogram, we can see a very simple bimodal distribution. So between 10 to 40%, we see essentially one hump of data, and then from 35 to 55%, or really 35 to 95%, we see another collection of countries. So very simply put, this becomes our boundaries, and we see that there's 134 countries in the opposing category, and there are 60 in the generally aligning category. And just to give you an idea, on the aligning side, all the way on the right, sort of a very, very aligned country with the US is Israel, as well as the UK in the, actually I believe 67%. And then surprisingly, China actually is, it's actually in this 35 to 40% bucket, but it does align with the United States quite a bit of amount of time. In the opposing side, we have countries like Syria, Libya, and Belarus. So the next step is tuning the model. So naive Bayes classifier is a machine learning model, and so it is necessary to tune hyperparameters. In this case, two different parameters, hyperparameters, were considered, and a grid search was performed to find the best combination. In this particular case, you can see two graphs here. One is measuring accuracy versus values of alpha while max term stays constant, and the other is measuring accuracy versus max terms with alpha staying constant. And just to explain, alpha is a smoothing parameter, or I believe it's Laplace smoothing in the algorithm I implemented, and max terms represents essentially the number of terms that are going to be considered from the human rights document when being submitted to the classifier. So you can see clear trends, thankfully, in both of these. As alpha goes up, accuracy goes down. So we want the lowest alpha, which is in fact 0. And same thing with max terms. So as max terms go up, we see a clear trend towards a better accuracy. So essentially what we ended up doing here is using all terms for max terms. So now we see some model results. So the first thing I'm going to do is show the baseline. This is just a simple majority classifier. So essentially a naive guessing machine that would just say, well, what's the maximum class category? I'm just going to guess that every time. In this particular case, if we remember from our previous graph, that would be opposing. So we would expect a roughly 69% accuracy. That's 134 over 194 would be approximately 100% recall, as it would catch every single state by simply guessing the majority class. Precision would be the same as accuracy, and we'd get a final F1 score of around 81.71%. Now what's really cool here is with the naive Bayes classifier, after training with the tuned hyperparameters, I was able to receive results of 87.89% accuracy, 94.29% recall, 88.52% precision, and finally a 91.31% F1 score. So hooray! These are great predictive results, and the hypothesis seems to hold. Remembering that our hypothesis is essentially that with this naive Bayes classifier, we would be able to better predict whether a country would be in that aligning or opposing category. So again, we see better results than we would if we just did a basic naive classifier. So the final thing I'm going to say is for anyone who's interested in this data set, like I had mentioned, it took a while to scrape and curate, but I have everything on my GitHub account here at this URL. So if you check this out, you can find the raw scrape files as well as the Python files I was using to scrape them. And also, probably the thing you do want to interact with is a SQL-like database, which contains raw text, relational entities like doc IDs, things like that, as well as the final processed terms, which were used in the naive Bayes classifier. And finally, here are my references. Thank you so much for watching this presentation.